Episode 11: Color Matching and Shade Control. Achieving Consistency in Automotive Coatings. In this episode, we focus on color matching and shade control, which are critical for ensuring consistent, high-quality automotive finishes. Automotive OEMs demand precise color reproduction across different vehicles, batches, and production facilities. Achieving this level of consistency requires a deep understanding of pigment behavior, measurement techniques, formulation strategies, and process control. Color in automotive coatings is determined by the combined optical effects of all pigments in the formulation, their particle size, refractive index, transparency, and interactions with the binder system. Even slight variations in pigment loading, dispersion quality, or particle morphology can shift hue, saturation, or brightness. Therefore, color matching begins with accurate measurement and characterization of both the target color and the pigments used to create it. Spectrophotometry is the primary tool for objective color measurement. Spectrophotometers measure the reflectance or transmittance of a coating film across the visible spectrum, providing precise data on L** lightness, A** red-green, and B** yellow-blue values. These parameters allow formulators to quantify color differences between batches and guide adjustments to pigment ratios. Advanced instruments also account for metamerism, the phenomenon where colors match under one light source but appear different under another. Metamerism is particularly critical in automotive coatings, where vehicles are viewed in daylight, artificial light, and showroom lighting. Formulation for color matching involves selecting pigments with appropriate hue, chroma, and opacity. Organic pigments provide bright, saturated colors, while inorganic pigments contribute stability, opacity, and durability. Extenders and carbon black can also influence tone and contrast. Achieving a precise match often requires iterative adjustment of pigment ratios, careful attention to particle size distribution, and consideration of pigment interactions. Even minor variations in pigment dispersion can affect visual appearance and must be controlled. Batch-to-batch reproducibility is another challenge. Pigments from different suppliers, production lots, or particle size distributions may have slightly different optical properties. Formulators use standardized pigment specifications, rigorous quality control, and master batch or intermediate color pastes to maintain consistency. Intermediate pastes allow precise pigment incorporation into the final binder system, reducing variability and ensuring uniform color across multiple production lines. Effect pigments, including metallic and pearlescent pigments, present additional complexity. Their optical effects depend not only on color, but also on flake orientation, thickness, and surface treatment. Small variations in effect pigment content, flake size, or dispersion can change flop, brightness, or color travel. Controlling application parameters such as flash-off time, coating thickness, and clear coat application is essential to maintain consistent visual effects. Temperature, humidity, and coating application method also influence color development. Solvent evaporation rates, binder flow, and pigment settling can alter final appearance. Formulators must consider environmental conditions in the factory and adjust processes or pigment formulations accordingly. Controlled drying, leveling agents, and rheology modifiers help minimize these variations. For large-scale automotive production, digital color formulation and predictive software are increasingly used. These systems integrate pigment databases, spectral data, and optical models to predict the final color of a coating formulation. While software provides an excellent starting point, human expertise is still required to adjust for nuances in pigment interactions, affect pigments, and environmental conditions. In addition to visual appearance, durability must be considered. Pigments must maintain consistent color over the lifetime of the vehicle, resisting fading, chalking, or yellowing. Organic pigments are particularly sensitive to UV degradation, while inorganic pigments provide long-term stability. Formulation strategies often combine pigments with stabilizers, UV absorbers, and protective coatings to maintain consistent shade over time. In summary, color matching and shade control in automotive coatings are a combination of science and precision. Understanding pigment behavior, measuring color accurately, controlling dispersion, managing batch variability, and optimizing application processes are all essential to achieving repeatable, high-quality automotive finishes. Mastery of these factors ensures that every vehicle, whether viewed under showroom lights or in natural daylight, meets exacting color standards. If you have any doubts about color matching, shade control, or pigment selection for consistent automotive finishes, leave your questions in the comments and I will clarify them.